Hey guys, so I'm back out on the 2504 for tonight. I only have about a half hour, 45 minutes. I want to get a little bit of stuff done on it. And I've got a big rock. I got a big thing I got to get working on this, and that's my oil pressure. When I first fired this thing up, it had probably 30, 35 psi of oil pressure. And since then, it's just dropped, right? It dropped down to maybe 10 psi at idle. Um, at PTO RPM, I'd get maybe close to 20. That means I probably have a blown out seal on my oil pump. So I went ahead and I preemptively ordered the seal and a new oil pan gasket. And I'm just going to drop the oil today and try to get that oil pan gasket, or try to get that oil pan off of there. When I do that, I also picked up a new oil filter. And so I'm going to go ahead and grab my wrenches, drop this oil pan, get the oil out of here, and see what we can see. A little bit of grit on this oil plug. Oil's black and nasty, but I don't hard. Alright, success. I was able to get that oil pan off. I just had to take this tie rod end off here to get the clearance to get it to twist on out of there. So now we can take a look and see what we have oil pan wise. And oil pump wise. So first of all, what do we have in here? We got some goop and some gunk and an oil pumped. We've got what's left of a dipstick. That feels kind of papery, rubbery, like right there. I don't know if you guys can see that. That looks to me like we've got a blown out gasket right there on the oil pump. Yep, I'd be willing to bet. Yeah, I can see a you can see a bow. You can see a bow in the bottom oil pump housing. Oh, it's blown out right there. Alright, so here's the deal. I got a new gasket, and I've got to decide if I can make this better. I think I can. I might. Yeah, check that out. See, my gasket blew out entirely there. It's blown out entirely there. And it was going to blow out there if it ever got to it. Alright, check that out. Let's look at their wear marks on there. I see just the tiniest bit of wear, right? Just barely skimming that surface. But what else do we see in here? I see a lot of scratches on there, right? That's not factory. That's not a machine finish. That's somebody with some sandpaper like I'm about to do. So it's highly likely someone's been in here before us. That's okay. We'll deck it down again, and this time we're going to reinforce it so that we can try to get try to keep it from bending away on us now, right? So the previous guys, if they decked that down and they took off 30 thousandths, and we've got 30 thousandths. Let's go inches. So that's 232 thousandths, right? So if it was 260, if it was a quarter inch at this flange, so 250 to 260, then we take off. They've already taken off. If they took off 30 thousandths, they took off 10% of the height of this. If I take off another 10%, the chances of that thing surviving are right between slim and none. So so we're not going to be able to deck this unless we reinforce it, and that's where I got a chunk of 1/4 inch, no, 3/8. I got some 3/8 plate that we will build into a cover to go around here. Then I've got to decide if I can bridge across there and keep this pressure relief valve clamped down. I think I can figure out a way to do that. So so we'll work on that part of it while we're stepping through this process. Alright, so if I look at this cover a little bit closer, see I have it marked right here. Definitely that's where one of my failures were, where the gasket blew out. Got it marked right there. That's another failure where the gasket blew out, and you can see that curve in both of these. Now on this side here where the pressure relief valve is, that line right there, this whole thing is bent up, right? And you can see this. Put this on a nice flat plate. Check that action out right here. Right, so we're pivoting right here. There is so much bend in there that I just don't think I'm going to be able to just sand or deck that away. I'm going to try to get rid of at least this bend, get this bend back closer. We're going to be reinforcing the top of it anyways. That'll prevent it from just bending back under operation. So we're going to go ahead and clamp this down, and then start clamping down the other side and try to bring this thing back down into compliance, back to where it belongs. All right, we're just going to go with a couple of clamps. I've got a nice wide piece here to distribute the force along the entire. So I got my total out of compliance, my rocking here, down to less than 60 thousandths, and that's still too much, but I'm not going to try to bend it anymore. I ended up using 3 thicknesses of shims underneath right here, clamped it down, and then kept clamping it down. I could try to do more, but I think it's time to just go ahead and try to deck it now. So. All right, we're going to start with some 100 grit sandpaper, a little oil on it. And this is what you call fine machining. Now I want to do less harm than good. See, we're starting to already knock down some of the high spots, and as we work through those high spots, you just want to get a nice flush surface. Started off with an aggressive sandpaper because I've got a lot of material to remove. It says in a precision tabletop, this is a surface out of a cubicle, right? But these melamine surfaces, they're stable and they're fairly flat. This is realistically flat enough. yeah, we're starting to definitely see the high spots that we're hitting first. I'll be here for a while. Still sanding away on it. You can see it's getting closer. I got some pretty good gouge marks from the sandpaper in there, but that'll polish up a little bit. I'm getting pretty hard, but the thing is you're sanding this thing down. Remember when we started with just a couple of small points? The more surface area that I have in contact with the sandpaper, the longer it's going to take, because that's the more material I need to remove. Well, it's not perfect, but I'm pretty happy with that. I've still got a little bit of gouges right there where the gears will be. It's going to be inconsequential when this thing's under operation. I just don't want to spend another half hour of sanding away on this to get those gouges out and weaken the whole overall structure. So I'm pretty happy with how that is. If you check out the gapping on this plate, there is no gapping, right? There's no rocking. So bending or forming this back to a solid plate and then sanding it down, I think this is going to work, guys. So I've got to build a clamp mechanism or a fixture, and we'll install it back in, but probably not today. It's already getting late. So here's what I came up with. Now, looking at it, I can understand it's not that visually appealing, but it's going to fit all of my needs, okay? So if we start from the top here, I've got a couple of just pieces of sheet metal that I can use to lock these bolts on when I tighten it down. Previous bolts were loose. They were barely tight, and that might be a problem contributing to blowing out gaskets. So I can torque these down, fold up a tab, keep these bolts from backing out. So I've got these two, what are these? These are 18 gauge. I probably could have went with 16, but I went with 18. So working the way top down. Now I can either go with, original is 3/4 inch 5/16. I could go with a 1 inch, which gives me another 1/4 inch of thread, but basically I'll be losing out on a 1/16 going in here. I think I'm going to try to go with 1.5 inches all the way around. So that's going to give me some extra thread, right? So an extra 3/8 of a thread on this side, but then on this side it's going to come out to be just about where we started. So on this side, I wanted to bridge and clamp down the pressure relief side. So I just took this piece of flat, notched it to clear the housing, and this flat is I think it's 3/16, 0.192. Quick, what's 0.192? 2/10. Yeah, that's 3/16. So I've got 3/16 plate. I just cut a notch out here. That's just going to provide some strength and tension. That's going to want to try to pull this apart when this wants to push up. So that's where steel is the strongest in tension. I think it'll work out great. Now for the spacing, to get the height correct, I took a couple of flat washers, and you can see I ground them down. They started off at 95 thousandths, and I ground them down to about 75 thousandths. I didn't get it perfect, right? It's belt grinder and a pair of vice grips, but this will allow this to clamp down, and without any force on here, I'm just barely touching the top of this oil cover. So as soon as I start tweaking that down, it's going to be just right. Now to do that, I had to make just this one little spacer, goes right there. It's not going to do a whole lot. It's not going to distribute a lot of force. It will distribute the force all along here instead of concentrating it right there. That'll be a win, right? That'll be a bonus. And then if I look at this piece, 3/8, and so remember, I had a blowout here and I had a blowout here. I also had this tweak up. This side seemed to be fine. I think that the extra rigidity from this feature, even though that has the weight hanging off of it, that kept this part, no blowout there. So it was right here and right here. So this takes care of that blowout and that blowout. They're not going to blow out. It's just, they're not going to happen. I torque that down, it's going to clamp it. This part's going to keep the pressure relief from tweaking up. I think I have fixed all the problems. I didn't take any measurements. I didn't measure this. I built these all just using cardboard templates off of the actual part. You know, at work I'd have had to drawn this up in a CAD package and get all the dimensions and tolerances, excuse me as I spit everywhere, get all the dimensions and tolerances just right. But here at home, that's not how I roll. So I've got it, everything to reassemble. Get it back on my holes in my 2x4. This is one of the things I like to do when I'm mocking stuff up. I just drilled 4 holes in this 2x4 on the same bolt spacing as my my housing here. And when I did that, I didn't even put my washers back in. That's a fail. But when I do that, it gives me a nice solid work platform that I can play with and manipulate. Come on, there we go. All right, of course I missed on one of those holes, but that's okay. So that's it, guys. Let's put this back together. I called up the folks at Steiner Tractor. I didn't call them, I emailed them. They sent me a new oil pump gasket and some Cowtails candies, which are, these are the most disgusting thing. Don't tell the guys at Steiner that, you know. Okay, wait a minute. If you do, tell the guys at Steiner's I'm a Whoppers guy. You send me some Whoppers, I'm a customer for life. Cowtails, not so much. So I'm not saying I'll go with a different supplier next time over the Cowtails. I totally won't. I think it's awesome. All right, let's put this thing back together. It's about 35 psi at idle. That's a win, right? So I know I've got more carb work to do. That's a given. It's not running right. We'll get that sorted out eventually. But right now, just waiting on tires. As soon as the rubber gets here, then we'll be able to, and then we'll be able to cruise. It's gonna be awesome. Talk to you later, guys.